Good afternoon, everyone, and welcome to Explore at Home, the Great Exhibition Road Festival's online event series. It's here that we blur the lines or cross boundaries that separate art from science, nature from technology, or innovation from cultural heritage. My name's James, and I'll be your host for this lunchtime deep dive into a fascinating upcoming space mission that scientists at Imperial, who are one of our festival partners, they are involved in. The Europa Clipper mission is a NASA voyage to an intriguing icy moon of Jupiter called Europa, which has long held interest to those hoping to find alien life. Today, we'll be exploring this mission through conversations with one of its scientists and, equally exciting, through the medium of space art. To do this, I need to introduce you all to two of my guests. Firstly, Dr. Tara Salter is an astrobiologist at Imperial, and today she'll be shedding some light on her work to better understand the basic building blocks of life so we can look for them on worlds beyond Earth. Thanks so much for joining us, Tara.
That's all right. Hello, James.
We're also joined by astronomical artist and astrophysics student Ash Wheeler, all the way from the US, who will be guiding us through creating our own alien landscapes. Hi, Ash. Thanks for joining us.
Hi, happy to be here.
Great. So throughout this event, Ash will be painting for you all to follow in real time. We have a little artist cam that we'll have. It'll be small sometimes and big other times when she wants to point out particular things. And I'll be sort of interrupting her annoyingly to ask her questions about what she's painting and how she became a space artist and all of that type of stuff. Before we get started, I just wanted to remind everyone that today is an interactive discussion, and we'd love to hear your thoughts, your comments, your questions. Just write to us on the YouTube chat function underneath, and we'll pass on your comments to Tara and Ash, and we'll chat about them online. Please do be considerate when posting in the chat. We will remove anything that disrupts the experience for others. Let's create a nice, friendly atmosphere for a nice conversation. Just to come to you first, Ash, in terms of people who might use this session as a bit of a tutorial to create their own artwork, what sort of materials do people need to have if they'd like to paint a bit like you paint today?
Of course. So first off, you definitely want to have something to paint on, whether it be paper like I have. I'm using just a multi-purpose durable paper. You can use canvas. You're going to need some paints. I'll be using some acrylic paints as well as a water cup. I've got a paint thinner. You don't need that. An assortment of brushes, a palette knife, an actual palette to put your paint on. I like to use a paint rag, some reference images, and some protective wear to keep your clothing safe.
Great, brilliant. Okay, thanks very much for that. So I'm going to leave you, Ash, just to start creating your landscape. So hopefully it'll be ready by the time we finish this event. So yeah, I'll leave you to get on, and I'm going to start off by finding out a little bit more about Tara, a bit more about the Clipper mission, and we'll come back to you in a bit. So if we can get started, Tara. I described you in the intro as an astrobiologist. I wonder if you can tell us what an astrobiologist is, and maybe a little bit about how you ended up becoming one.
So the short explanation of what an astrobiologist is someone who studies the possibility of life in space. Now that can be absolutely anything. That could be searching for life that might have been there on planets such as Mars, searching for the signatures of life, the chemical signatures of life on somewhere like Europa. It could also be looking for life on exoplanets, as well as looking on Earth for life in extreme environments and trying to work out where the origin of life on Earth came from that could then be applied to space. So it covers all sorts of different things, the term astrobiology. And at the same time, it covers basically the whole of science. It's a very multidisciplinary topic, covering everything from physics to chemistry, biology as it's in the title, even engineering. And so my route into astrobiology, I originally studied physics. And then after that, I've been working in the area of analytical chemistry. So using different techniques to look at chemical compositions of a whole range of different materials. And now I work at the Earth Sciences department at Imperial College. And this is where I do astrobiology.
Great. Brilliant. Thanks. Yeah, thanks so much. It's a very multidisciplinary area where you get scientists from all different backgrounds working on this. I mean, this huge yes, huge problem or a huge question that I think we've had that
Yeah.
humans have been battling with for so long. It brings together all these different sort of scientific disciplines.
Yeah, it's a real melting pot of ideas. A lot going on, a lot of different ideas.
Yeah, and the fact that you can like an astrobiologist can actually be quite Earth focused, I guess. We'll unpack that a bit later on, but that's quite an interesting concept. You're not always looking out into space. We're often spending time on Earth, looking at Earth biological systems, which is really interesting. So you talked about some of the places where astrobiologists are looking for signs of life. So some within our solar system, some a lot further out, I guess. We're looking today in particular at a world, a moon that is very much within our solar system and has been visited a couple of times in the past, but is going to be visited again by this Europa Clipper mission. And that's the moon Europa, as in the title. Can you tell us a little bit about Europa? Tell us a little bit about this world.
Yeah, so as you say, Europa is one of Jupiter's moons, and Jupiter actually has, I think at the latest count, approximately 80 moons, some of them tiny, some of them reasonably large. So Europa is actually only slightly smaller than the moon of our Earth and Moon. It's believed that it has an ice shell. So this ice shell supposedly covers the whole of the moon. And underneath this ice shell is an ocean, actually also covering the whole of the moon. So the ice shell is supposedly between about 10 and 25 kilometers thick. So it's quite a substantial shell. But the ocean underneath is maybe up to 100, 150 kilometers thick. Whoa. So it's quite an incredible place. And it's far out into space. It's much further out from the sun than we are at Earth. So Jupiter is beyond Mars, beyond the asteroid belt, and then you reach Jupiter. So not much sunlight actually gets there.
Yeah,
but
nice.
That's why it's an intriguing place.
Yeah. So I think we think of like oceans on Earth as sort of sitting on the surface in a sense, filling in like the lowlands. Sort of think of them as, and they're sort of discrete areas, though they are kind of joined up. I guess they're sort of discrete areas. This is a whole. This is more like when you've seen like cross sections through a planet. You've got a whole layer in that sort of. It's a bit like it looks a bit like a cake. You've got a whole layer, a thick layer of ocean which goes round the whole world. It's a very different concept of an ocean, I guess.
It really is. And actually, if there is an ocean there, even though Europa itself is quite a bit smaller than Earth, the amount of water in the ocean on Europa would be more than the amount of water in the oceans on Earth.
Oh, amazing! So yeah, even it's a tiny world, or relative to the Earth, the size of our own moon, because it's creating this huge layer within the actual makeup of the moon, rather than just sitting on the surface of the planet like our oceans. There's more water there than there is in all our oceans. It's incredible. Brilliant. So we love a bit of sort of pop culture in Explore at Home, and Europa has actually been featured a number of times as a setting for TV and films. I think we have a couple of slides showing its depiction on that's Futurama, the Matt Groening American cartoon. And then in 2013, the science fiction film Europa Report, which I haven't seen, but I don't know how much money it made in the box office, but it was set on Europa. I guess both of those maybe start to give us a sense of what it would like to be sort of standing on the surface of this icy moon. I wonder if you can sort of paint us a picture yourself, Tara, based on what we know about what the surface of that moon might be like.
Yeah, so actually that picture of Europa Report might be quite real. I mean, the images we have of Europa are not very detailed so far, and that's one of the aims of Clipper, to get better images. But it's thought that it's, as I said before, covered in ice. And then you also get these ridges that span thousands of kilometers across the surface of the moon. And those can be a couple of kilometers wide and maybe 100 or so kilometers deep. So you could have somebody stood at the bottom of one of those ridges looking up into this sheer ice face. What I would also say is that you wouldn't really want to be stood on the surface of Europa. Firstly, it's going to be very, very cold. You're far from the sun, as I said before. It's not going to be very pleasant. There's not a very big atmosphere. There's a very tenuous atmosphere, so you need some breathing material of your own if you're actually on the surface. And the third thing is there's a really harsh radiation field coming from Jupiter. So the radiation that hits you if you're stood on Europa might even kill you. So it's not a place where you'd want to go on holiday, I would say.
And it's that thin atmosphere is part of the reason why, if there is life there, it's not going to be sitting on the surface. It's going to be in the ocean. It's sort of anything that's on the surface is just exposed to the. They say that space is always trying to kill you. Or like if you don't have an atmosphere, you're completely sort of exposed to it, I guess.
Yeah, not a very nice place. So underneath the surface of the ice, that is where it's really interesting.
So it's I guess the surface of ice can provide sort of a little shield, I guess, or from at least some of the, if not all of the sort of the deadly radiation that might be bombarding the surface from sort of the space environment in which this moon sits. Yeah,
because the ice crust is supposedly really, really thick. It should stop any of that radiation going down into the ocean.
Ash, I was just going to come to you. How are you getting on? Can you, we've been talking about the sort of the landscapes or the surface, and that's what your piece is sort of from that perspective, I guess, is what you were looking at doing today. Is that right?
Right. Yeah. Currently, I'm kind of setting up the foundation, establishing layers, allowing each layer to dry, so that way we can build more layers to create that level of reality in order for it to seem realistic, which is a goal of mine. And in all of my paintings that I do, I want to project an image of reality in a way that maybe instrumentation can't do yet. So currently I am painting the kind of icy terrain that Tara described. It's kind of this silvery, very, very faint blue color. And I'm just kind of setting up each layer. I'm not sure if mountains is the correct term, but as you could see in that movie poster that Tara was just saying is a pretty accurate depiction of what we would expect Europa to look like. I'm kind of creating these crevices and these smaller mountains to just kind of set the stage, and then Jupiter being in the background and all of its terror and beauty. So just working in layers right now. I'm trying to kind of set up the icy mountainous landscape. So
I don't know. I find the sort of the idea of the size of Jupiter would be quite intimidating. It would be beautiful, I guess, in a sense, but like the amount of sky it would take up, I find that quite intimidating, or a bit looming over us, I guess. I'm not sure. Right. So in terms of your own sort of practice, Ash, if we can sort of delve into that, you talked about it's been an interesting journey and how this sort of space art has fit into your career, I guess, and sort of influence your decisions around what you want to do for a living. I wonder if you can give us a bit of a synopsis about how this came about and what role it plays in your day-to-day life at the moment.
Sure. So I started at university with a studio art major in drawing and painting, and I was about to graduate, maybe two semesters away, and I realized that my true passion was for astronomy, which growing up, math and science, those subjects weren't my strongest. And I just heard, the statement echoed that you should pursue a career in something that you are naturally, more gifted at, talented in. And so I just thought math and science, something I'd had to try really, really hard at growing up. So I just thought a career in something in STEM would be a struggle. So I just didn't really even give it the time of day. And I took a few astronomy classes towards the end of my art degree to fulfill my science requirement. And in those classes, I just found myself more excited than I'd ever been about anything. I was running home and telling my parents all about the solar system and everything that I had learned. And it was a love like not anything I had experienced for art up until that point. So I decided to make this decision to change my major as a senior in college to physics with a concentration in astronomy. So I've been doing that since 2018. It's been a long road because, as you can imagine, the prerequisites for an art degree versus an astrophysics degree are quite different in terms of the math department. So that's a lot of math. Physics is mostly math. So yeah, I've been doing that, and the pandemic kind of threw a wrench in my degree and prolonged it a little bit more than I would like, but I'm set to graduate here in a few years, and I want to work for NASA one day. It's my dream job. And so how I got here is, as I was pursuing astrophysics in school, I still desperately wanted to create. I still found myself trying to fulfill that outlet in my life. And I painted the moon one day, our moon, Earth's moon, and I was just so inspired by that and started learning about all of the spherical moons of the solar system, and just saw an opportunity to create something and educate people in a way that was new and fresh via social media. So I created my own business, kind of centered around portraying things in the universe in a realistic way, and just kind of bringing the sky down here on Earth and into people's homes. And I've been doing that ever since, and I've fortunately had great success in that, and it's my job while I'm in college. So yeah, that's how I've gotten here.
Amazing. Yeah, a lot of people tend bars or work in supermarkets or retail to sort of earn a bit of extra money whilst they're at college or university. But yeah, you're doing something that you're really passionate about on the side of your studying, which is that's amazing.
Thank you. Yeah.
Second thing I was going to ask you before I let you get back, you mentioned to us beforehand that this wasn't just completely coming from your own imagination. You were drawing on some inspiration for the particular landscapes that you had been researching, including one drawn from Hollywood, which I thought was quite interesting. I think we've got a couple of your source images that we can show up. I wonder if you can talk through some of these that are sort of inspiring today's art.
Yes. Yeah. So I'm not sure if anyone will recognize it, but the top left image is actually from the Christopher Nolan film Interstellar, which is the inspiration of my life. No, I'm just kidding. I really, really admire that movie, and I admire the just the advisement that was given to Christopher Nolan through just scientists. And so this landscape reminded me of a lot of the images that I've seen constructed by graphic designers for NASA and things like that. And they actually took these images and filmed these scenes in, I believe, Iceland and Alberta. And obviously through editing and things like that, I just felt like this scene in particular, as well as other Icelandic landscapes, kind of gave us the closest, taste of what Europa would actually feel and look like. So through modification and things like that, obviously these kind of crevices that you see portrayed in the top left image, they have like this grayish hue to them. I will be substituting that kind of rusty color that we see on Europa in its place, just subtly, because it's not too overpowering, just enough to notice. And then the bottom left image of a geyser, I'm going to be inserting into one of these crevices to show a portrayal of, the geysers or the plumes that we might see and expect on Europa. And then obviously Jupiter as the looming ominous planet in the background. So, yeah.
We had a question. Well, we had a comment from Alessandra who described your work as beautiful. Ash, it's beautiful. So that's great to hear. And we had a question from David from Hackney who just asked what the best paints to use. So what paints are you using today? What's your advice for sort of space art paints?
Yeah, so I have evolved my painting process quite a bit over the years. And I started out just using the most basic paints. There's nothing wrong with them. As you advance in your choices and your budget in terms of paints, the quality just obviously increases. And I actually found a brand of paints called Golden. I use a line called Open. So it's an acrylic paint. Let me see, put it in this can, with the tendencies of oils. So I like the movability of oils in the sense that you can manipulate it for hours on end. The dry time is really, really long. So the Golden Open line kind of mimics that trait of oils, and that you can let your painting rest, come back to it in a few hours, and still that paint is still wet and workable. So those are the kind of paints that I use, and I actually dilute the paint with this thinner. It just kind of acts like water, but more dense, so that way your paint can glide more seamlessly across the surface that you're painting on. So yeah, that's highly, highly recommend. I've been using them for a few years now. So yeah.
Okay, thanks. Yeah, thanks for that. That was useful, David. I'm going to leave you to get on, Ash, now and continue creating your piece. Tara, I'd like to explore sort of the biology bit of astrobiology, I guess, now. So we kind of painted, we sort of set Europa, the scene of Europa, I guess, kind of literally, I guess, in a sense, and we sort of introduced that moon. But let's talk biology. And actually, I'm going to go to science fiction again, if that's okay. I don't know if most people will have seen 2001: A Space Odyssey. Maybe less people will have seen some of the sort of sequels to that, to the film, or read the sequels to Arthur C. Clarke's original book. But in those sequels, you get aliens taking an interest in some primitive life forms that form under Europa's ice. So it's quite interesting that even back then, this idea of life in this ocean was a possibility that was intriguing literary writers. So this is obviously fictional, but potentially possible, I guess. But what we do know is that there are things living on Earth today, Tara, that would likely be absolutely fine, or at least survive and reproduce if we release them into Europa's ocean, based on what, I guess, our assumptions as to what that ocean contains. And I wonder if you can tell us about some of these organisms, where they live on Earth. How tough are they?
Yeah, so it is actually really incredible. And this is only things that have been discovered in the last 20, 30, 40 years. So relatively recent discoveries, that there are actually microorganisms, sort of the class of bacteria and archaea. So single-celled organisms, nothing very complicated. But they've been found living in really extreme places. So one example is a lake in Antarctica that's probably as salty as the Dead Sea, so very, very salty. And as it's so salty, the temperature in the lake can get down to minus 20 degrees Celsius. So very cold, very salty environment. And bacteria and archaea have been found there, and not only surviving, thriving and growing and reproducing. So that's one example of a really crazy place, which could be similar to environments we find on Europa. And then at the other end of the scale, under the ocean, at hydrothermal vents, bacteria have been found. So these are places where the water is hot. The water can get up to 300 degrees Celsius. Such as the picture here, shown of a hydrothermal vent, or also known as black smokers. And that's also a strange environment because it's deep on the ocean floor, so it's far away from any sunlight that could get there, and we often think that life needs some sort of sun or warmth from the sun to survive, but this just shows that they can survive in dark places where the chemical environment is also quite harsh. And another example of a harsh chemical environment is acidic volcanic springs, so where you get pH of down to approximately 2 or something, so really acidic environments, and bacteria have been found to live in those places as well. So really some crazy places that we as humans would not survive in without any special conditions, but bacteria are quite happy there.
Yeah. So we hear the thing like life phrases like life finds a way or something like that about Earth,
Yeah.
and people sort of sit back and go, "Oh, that's lovely." But actually, from an sort of an astrobiology perspective, it's exciting in a different way, because it suggests, well, if life is happy in these conditions on Earth, then certainly it opens up environments on other planets as being habitable that maybe we didn't think were habitable because they don't suit us in particular, or some of the species that we're sort of more familiar with, I guess.
Yeah, definitely. I mean, if there are just a few certain conditions, I guess, then any life can survive in any strange place. It's quite remarkable. Well, and I think more discoveries will actually be made on Earth in the future of life living in even stranger environments. It seems that wherever we look for life on Earth, we find it. If we look hard enough, it is there.
And I guess the other thing, the one thing that, well, maybe I don't know, the one ingredient that seems to be generally important, which I guess why the ocean on Europa is intriguing, is water on Earth. Is that so? Water seems to be the one thing that you kind of need to have in some form and at some level, certainly for the sort of type of life that we sort of recognise, I guess.
Yeah,
we have that in Europa, I guess.
Well, we hope so. It's not 100% confirmed that there is an ocean, which is one of the aims of the Clipper mission, to find out more about if there is an ocean. But yeah, water is one of the key ingredients. So there's basically 3 key ingredients that are needed, or that we think are needed based on our earthly view of what is required for life. So one of those, as you say, is water. The other is the right sort of chemicals, such as carbon, oxygen, nitrogen. And then the third thing is some sort of energy or heat or something to sustain life. And we believe that Europa might have all 3 of these. So that's why it's the most promising place in the solar system to look for life, because it has all of these 3 ingredients.
Yeah, I wonder if could we bring back the picture of the black smoker, the chimney, the sea floor picture, if we could do, because essentially we're talking about a moon that has an ocean, but the implication of that is it also has an ocean floor at some point, right? So this is the bottom of one of Earth's oceans, and I mean it looks really like lit up here, but that's because it's like there's a submersible has lit it up. It's pitch black. It's very acidic, or it's all the whole pressure of the ocean is crushing everything from above, and it's freezing cold and it's not particularly hospitable. Yet here, everything that doesn't look like a rock probably isn't a rock, or and very well be alive. I think the red things are all alive. There's probably things feeding off the red things.
A whole ecosystem going on down there. Quite remarkable, as you say, at the bottom of the ocean, in the depths, in a really sort of strange place, strange world. But and so on Europa, there may also be these as well. So as you say, at the bottom of an ocean, it's not, the planet is not just water. There is something that the water sits on, which is believed to be a bit like the Earth, that it has an iron core and a rocky mantle around that core, and then the ocean.
So if you imagine that, like that layer cake analogy again, when you've seen the Earth, you've got like there's a ball in the middle, which is kind of like the core, and I think you've got an outer core, which is slightly different, and then you've got the mantle, which is the sort of semi-melted rock layer, which is really, really thick, and then you've got the little crust on top, which is the sort of outer layer. So whereas in Europa, are you saying it's like some sort of, there's a rocky ball or something in the middle, and then and then the big thick bit is water, and then you've got a thicker than quite a decently thick ice bit around the outside. So you've got that still at the bottom of that ocean. You've still got that sort of rock to water
interface. And that's really important, actually, because at the rock to water interface, you get lots of interaction between different minerals and things that you might have in your rock and the water. So you've got a whole cycle of different elements happening, and you also get a source of heat and source of energy from Jupiter, actually. So as the moon goes around the Earth, we get tides and we get the gravitational pull between the 2 planets. You get that happening between Jupiter and its moons. But you can imagine it's quite different, because as Europa is, as I said, this similar size to our moon, Jupiter is much, much, much bigger than the Earth. So the gravitational pull between them is actually much larger. And so as Europa orbits around Jupiter, you get this gravitational pull, and you get tides happening on Europa, and this flexes the water and the crust on the planet, and sort of provides a source of heat and energy, which could sort of start these hydrothermal vents occurring on the surface of the rocky core.
Yeah, people talk about the analogy of like if you bend a spoon and then you touch the bit that's bent, it's warm. It warms it warms the spoon up. So if you sort of do like a spoon bending trick, so the idea of Jupiter actually warps or bends the sort of the very fabric of the moon and creates heat, and that heat could I guess create something akin to that image of those black smokers on the bottom of the ocean. And like I said, all those places where people think about. So we talked about sort of life happily living, like habitable conditions, i.e. life. If we took life and sent it to that moon and dropped it into the ocean, it would be quite happy. But there's a whole different scenario, a whole different question is around the origin of life, which is like how did life form? Because you can't, it's unlikely. I don't know. It's unlikely that life parachuted into Europa, and if we find life there, it's unlikely to possibly to have been parachuted in. It's more likely to have formed there. So it's all very well and good being habitable, but you also have to have the conditions to sort of create life. And I guess that's a little bit more difficult because we might not. I don't know if we know enough about how it formed on Earth to be able to sort of say how it might form elsewhere. But that is a different question, isn't it?
Yeah, a completely different question, and that's why astrobiology is also concerned with things on Earth. Like we don't understand yet the origin of life on Earth. So trying to understand the origin of life elsewhere is even more difficult. And so and as you say, we can have a place that has habitable conditions, so it can have everything that you'd need for life, but that doesn't necessarily mean there will be life there. So it's two different questions, but they're sort of linked, but could be answerable in separate ways as well.
Yeah, I guess it seems to be all the places where people are sort of looking at have suggested for the sort of early life on Earth. There's sort of there's water, there's like minerals from deep within the Earth. There's like an energy source, like those. There are some of those, at least if not all of them, are sort of ticked to an extent for Europa. Like we have some of them, so there's possibilities there. It's intriguing.
It is very intriguing. That's why the Europa Clipper is a very intriguing mission, and what it will find is very exciting.
So that's a great, wonderful segue into what I was going to ask you next, which is about this mission as well. So we sort of set this up as this really intriguing place that is in the solar system that we've sort of been interested in, and we have visited it. I think sort of Voyager or a couple of those missions sort of flew by pictures. But is that the extent? We haven't. I don't think we've looked at it in as much detail as we're planning with you.
No one has been there. So the only there's been several missions that have gone past Europa when they've been looking at Jupiter and other places, but nowhere has gone specifically to Europa to look at it and to try and answer these questions that we have about it. So we've been intrigued about it for a while, but Europa Clipper is the first mission actually dedicated to go there. And so Europa Clipper is due to launch in 2 years' time in 2024. This is a picture of the spacecraft, and it will take actually 6 years to get there. So we're not expecting any data back till 2030. So this is quite a long time. And it is actually quite a big spacecraft. I was in a meeting earlier this week with some of the top Europa Clipper guys, and they described it as a beast. It's, I think, one of NASA's largest sort of planetary missions. And it's not intended to land. It's not going to land at all. Actually, it's going to fly by and orbit Europa, as well as having sort of a bit of a closer look at some of the other moons and Jupiter as it goes past. And this is a really interesting spacecraft, and it'll have 10 different instruments on board. And between the combination of all of these different instruments, it's trying to answer different questions about Europa. So what's the ice crust like? Is there an ocean? What's the ocean like? So it has instruments that will, cameras that will be able to take pictures of the surface in really high definition, much better than anything that we've got previously. And then it will have radar and other instruments that will be able to look through the ice crust and be able to look at the ocean underneath and look at the core and be able to make better assessments of what that is made of as well. And then it will also have instruments that can look at the chemical composition of the surface. So there's an infrared spectrometer, which will be able to look at the chemical composition of the surface. And then it also has a couple of mass spectrometers on board, which is the really exciting bit, because mass spectrometry is what I do. Mm-hmm. And so mass spectrometer is basically a weighing scale for molecules. So this actually requires actual material to be sampled. And it can do this either looking at the very tenuous atmosphere or what's around Europa. But what we also hope will be on Europa are plumes. So there is a moon of Saturn called Enceladus, which Cassini visited about 10 years ago and discovered there was plumes there. And this is very exciting because the spacecraft can fly through the plumes and sample the material that comes directly from the ocean or from other water pockets on the ice crust, as shown in this artistic impression here. So water ejecting up out of the ocean through cracks in the crust. And it's hoped, and possibly thought, there is some evidence that Europa does also have plumes. And so as the spacecraft flies through these plumes, it will be able to pick up material that's in there and analyze it and be able to work out the chemical composition, so the elements that are in there, but also if there are any more complicated molecules, and if there are any molecules that could come from life as well. So it's a very, very, very exciting mission. I look forward to seeing what happens when we get the results in 8 years' time.
I was going to say, the first thing that I was going to pick up on what you said there was like how long it's going to take to get there. you have to be really patient in sort of any astro science. Seems to, and especially sort of planet solar system exploration. You have to. There's a lot of work goes into it, and then you have to just sort of sit there and wait. Well, not slowly, it's going fast, but it's like it just takes a long time to get there.
It does take a long time. You don't realize how far away it really is. You think, oh, it's in our solar system, it's close by. No, it's actually quite far.
And the plumes are these sort of outpourings. I mean, I guess that they're both an amazing sort of confirmation. Certainly for Enceladus, they were a sort of a confirmation that there was this ocean below the crust of this in this case a moon of Saturn, but they're also like a real handy. They're a really handy phenomenon for scientists who want to maybe find out what that ocean's about and what's in there, because you don't have, as you said, like Europa's not the Clipper isn't landing. It's not. No. I think when people think about sampling an ocean moon, the ocean of a moon, they're thinking of, well, I guess I was thinking you land, you maybe drill down some sort of mole-looking device that drills down through the crust and then starts swimming around in the ocean, which is amazing, but I guess quite that
would be a lot of engineering.
Yeah, good luck with the engineering team. But you don't have to do that. The moon is kind of sending out bits of its ocean and so a flyby mission, maybe with a sort of little open capsule that can sort of collect some of that. I guess it's ocean spray or an equivalent of ocean spray, and then you can find out what's in that ocean spray. So yeah, it's a sort of an amazing phenomenon, but also quite a convenient phenomenon for making these missions a bit more possible and less of an engineering headache, I guess.
Yeah, well, let's hope they're there, so it is possible.
So when we're talking about what we can, we've captured a bit of this ocean spray, fingers crossed, in Europa, and we're looking. I guess there's like geologists and oceanographers might be interested in all sorts of sort of chemicals and molecules that might be in that ocean because they can tell us things about the subsurface and stuff. But from an astrobiology perspective, I guess are you looking for things to actually be living in that sample, or what can you find in there that is, from an astrobiology perspective, would raise an eyebrow or sort of cause you to shout eureka or just get you excited?
Well, I don't think you would be able to detect actual individual bits of life. I think anything that you're going to detect will probably be blown apart a bit. So what you're looking for is sort of, as we said before, the ingredients of life. So maybe elements, but I would be more interested in bigger, larger molecules. So you look at looking at sort of parts that could come from the protein structure. So things such as amino acids, things that could come from lipids, such as fatty acids. So actually, this is what I've been doing in my research at Imperial, where I take extremophiles from Earth and I put them into the mass spectrometer, sort of blow them apart as such, and see what they're made up of, and then look for the different patterns that we get from all of the different components in them, and try and build up a database or a library to say, oh, if you find molecules X, Y, and Z, that points in a really good direction that you could have something interesting there, something that could come from life. And we find that on Earth, the molecules that originate from life, they're sort of very specific molecules, and they're also reasonably complicated molecules. And the great thing about the instruments aboard Europa Clipper, the mass spectrometer aboard Europa Clipper, is it's built with that intention in mind, that it's looking for larger, sort of more complicated molecules. So it's a really high spec mass spectrometer that is designed to look for some interesting molecules that might be there to tell us if there is life. So I think you can detect certain things that will tell you if you have the right conditions for life, so the right ingredients for things to be there. But then you should also be able to detect sort of molecules that originate from life. And that's sort of also based on our earthly perspective. So what we think life needs would be made up of on Earth. Yeah. And it could be that life in space, if it started from a completely different origin, it could have some completely different chemistry. And we have no idea. But until we go there and start collecting data and then looking at it, and then we go, oh, this is maybe more interesting than what we thought we could have had.
Yeah, I guess the principle, it might very well be the case, be different from what we have here, but I guess you have to at least go with the sense of looking for the stuff that the one example that we know of life in the universe looks like this. So you might as well look for that initially. I guess that makes sense. I guess it's interesting, the idea that, I guess it's the same for our own oceans, that the oceans aren't just like a passive background, like, they are influenced by the life in it. And I guess if you know how to look for the signatures, you can tell what's a little bit about it, or a lot about maybe the things swimming around in that ocean just by sampling the ocean themselves. So it's kind of this, I guess it's the same principle, just for a different ocean or for a different.
A similar analogy. I mean, who knows if the oceans are greatly populated or whether they're sparsely populated, if populated at all, with anything. The oceans on Earth are quite well inhabited by all sorts of small microorganisms up to larger things, to very large whales. So yeah, who knows on Europa what might be there.
We had a question from David, who's asked about the sort of he started to think about the type of life that would exist on Europa, and what sort of evolution, I guess, it might need to go through. So he's talked about whether we might expect bioluminescence in the dark oceans of Europa. I guess, I don't know. I guess that sounds plausible.
I don't know. It could be plausible. I guess they would have to have some reason to luminesce. So
yes, so some organisms are happy in the dark. I guess they don't have to.
That could be possible. I guess a bioluminescent organism is maybe something that's evolved to be more complicated than a single cell organism, which is sort of what we think as the base block. But who knows what could actually be there on Europa. Bioluminescence may be there or may not be.
Brilliant. That's a great question, David. Yeah, it's a really interesting. I guess, what we probably would expect the environment to influence in the same way it does on Earth. If there is life there, to influence the environment, whether it has allowed sort of complex organisms with bioluminescence, I guess we'll have to wait and see. Ash, I wonder if I can come back to you now, just to check in on you. How's it going? We can make your artwork nice and big so everyone can see how you're getting on.
Yeah, going great.
Oh, wow, yeah.
Constantly adding dimension. this bottom part, the actual landscape of the ice mountains, what I perceive them to be, is really the bulk of this work, because Jupiter is just going to kind of exist in the background. The main focus is going to be the crevices and, you know, the rust colored cracks in the ice. But really setting up, ice is complicated, and it, you know, reflects light, as well as, you know, these crevices that go way deep into Europa. It's all about, you know, shadows and highlights. So it takes a while to establish that. But once it gets towards the latter part of the process, you can really start to see where it actually looks like something that exists. It just takes a while to just blend your heart out, and yeah, just make sure that the colors are right and you're creating texture.
Yeah, so I was going to say, that's the thing, the word I was going to say, like comparing it to when I last checked in on you, like texture is that, you know, that feels like compacted ice, or it feels familiar in terms of the sort of icy landscapes that we see on Earth. I guess I definitely can. Yeah. There's definitely a sort of a textural feel to how that's just a blending technique you've used across the landscape.
Yeah. I established, for those of you that are painting along, I kind of set up a strong base layer along this back ridge, where that icy blue is more potent and solid in color. And then as you get closer, like if you were standing right here and you were looking out, that's where more texture is going to come in. That's where the crevices you can see. Currently, right now, I'm adding in these really, really dark gray areas and just kind of building that reality out. But yeah, a lot of texture, just taking the edge of your brush and feathering and creating, even if it looks imperfect, sometimes that can create something even more realistic than we could contrive with our own human hands. So yeah,
nature doesn't create perfect straight lines often, or objects very often. So yeah, it creates a more natural feel.
Right.
I don't know if then, Ashley, if there's anything you're planning to depict or have depicted that you want to ask Tara about in terms of what we because I know you're working from a limited sort of actual photos. We don't know what this landscape looks like. So I don't know if there's anything you want to ask Tara about.
Yeah, so in creating Europa and this base color that I've used and this icy blue, sometimes in images you can see different filters used, and that the blue is almost turquoise in a way. There's a little bit of a green hue at times. Does it lean more icy blue or more kind of polluted, slightly green? Is there a way to know that color, which way it leans?
So, it's very difficult at the moment sort of to know which exactly it is. But a lot of the pictures you see are actually either false colors or enhanced colors. So where they've taken, such as here. So the picture on the left with the sort of yellower tones, I think that's how it would really be, sort of a dirty ice. Whereas the picture on the right with the more blue, that's where it's been enhanced. So you can sort of see the differences between sort of the different parts of the ice. And then you have the areas in brown, which could be some sort of contaminant or something. They've detected salt, so just your common table salt, sodium chloride, has been detected on the surface of Europa, as well as other salts. So those sort of browny regions are thought to be contaminants, salts, maybe some other things. More questions for Europa Clipper to answer when it gets up there, what actually the surface is made up of.
Very true. Wow, thank you for enlightening me. I feel like I can go into my practice now with a more realistic approach.
So what's your final pieces? Are you gonna what do you think we'll be able to do in the last 10 minutes to add to your piece?
Yeah, so I'm probably going to finish up this gray and go in and add a few of that, a few kind of crevices in that rust colored, as well as a geyser, probably about right here in this crevice, and then just kind of give the feel of Jupiter without being too precise. Of course, if you have more time on your hands, you can go way into detail on this. So yeah.
Brilliant. Okay, we'll check back with you in about 10 minutes and see where we've got to by then. Yeah, and afterwards if you, we'll post a picture of it up on the Great Exhibition Road Festival's Twitter and Facebook. The final piece on the Twitter and Facebook, so everyone can see it there, and we'll send it to everyone who registered for this event. So Tara, I want to come back to I guess the biology question, I guess, and we talked a little bit about this. I have a final science fiction reference, which is related to Europa, which is Jeff Carlson's Frozen Sky trilogy of 3 novels, and in that he describes sort of intelligent alien life form discovered living in the oceans of Europa, which actually is older than mankind, apparently. Again, I haven't read these, unfortunately. I assume that that's probably at the more unrealistic end of the spectrum as to what we might find. But what do you think? What can we say about the most likely type of life that we might to find swimming around in those oceans of Europa and maybe Enceladus as well?
So yeah, we're probably very unlikely to find intelligent life, and possibly even quite unlikely to find sort of life that's maybe multicellular. So yeah, we're really looking for very simple single cellular organisms, extremophiles, things that can live in simple environments. Nothing too complicated. So things that obviously can swim probably in an ocean. And you might have them in different parts of the ocean, and they might be adapted to live. So if we imagine that there are hydrothermal vents on the ocean floor, they could be completely different organisms to those that are living halfway or at the top of the ocean. Sort of maybe there'll be something living between where the ocean meets the ice crust, which we'd imagine would be really, really adapted to the cold environment. So that sort of organism, rather than anything that's evolved to be more complicated. I mean, it is a fascinating question to know if there is anything there and what it could be and what that would mean for how life has evolved on Earth as well. It opens, I think the more we find out, the more questions there will be to ask about life in general.
Yeah, absolutely. Yeah, we can learn more about ourselves from looking out beyond the Earth. I guess some people might be, slightly they'd be disappointed, I guess, in a sense, because we've talked in the first sort of half of this about how the some of the environments we might find in Europa are no different to those on Earth, and he showed that black smoker, and there's all sorts of weird like shrimp type things and all sorts of like creatures there. But I think one point is life on that sort of single cellular life on in the history of Earth, that was all that was there for the majority of time that life's been on Earth. It was really simple. Yeah. Like we're living in the sort of the kind of the exception at the end, towards the end of towards the modern day. But actually, for the billions of years, or the majority of time that life formed on Earth, it was really simple organisms. And I guess maybe that tells you something about what to expect. I don't know what you think about that.
Yeah, no, it does. Definitely that life did probably take quite a while to evolve, and the few first millions of time was dominated by very, very simple organisms. So that is why we think there's possibly nothing, if there is life, there would be nothing more complicated than that on Europa, just because the time it takes to evolve something more intelligent or something even larger just takes so long. And we don't know how long Europa, if it has an ocean, how long it's had an ocean for, or any of these questions. We don't know the answers to.
Yeah. So the history of the moon, is uncertain, I guess.
Yeah.
Are there sort of limitations, sort of biologically, or in terms of biological analysis of a flyby attempt? Is there a case? I know we talked about the engineering challenges of this, but is there a case if Europa Clipper finds there's ocean, not only confirms that there is an ocean underneath that moon's icy crust, but also finds some tantalizing clues of habitability, or maybe even something more like lifelike, I guess, in terms of a sort of a protein structure? I don't know. Is there something that a mission, maybe a far off mission that lands or dives, is there a justification for that, do you think?
Yeah, definitely. And in fact, one of the sort of aims of Europa Clipper is to survey Europa and to understand where might be a good place to land. So there's actually a proposal that has a follow-up mission to Europa Clipper, so that while Europa Clipper is there gaining evidence of what's there, what the surface is like, if there would be anywhere to land, because we don't know what the surface up close is like, what it's on, like a meter or so scale, which you would need to know if it was safe to land or not. But people have been developing proposals for going there, landing there. Obviously, a landing mission is a much more complicated engineering feat than an orbiting mission, as we've seen from missions that land on Mars or try to land on Mars. Not all of them succeed. So landing on something further away like Europa would be more complicated. But there's definitely ideas for follow-up. No concrete plans yet to have a follow-up, but definitely there's a lot of people who would like to see that. And also, as well as Europa, people would have been putting forward proposals to go back to Enceladus and to land on Enceladus, because we know there is plumes there, that we know that there are cracks where you could maybe go down into the ocean. People have tried to think of ways that you could easily get down through those cracks to sample the ocean on Enceladus. So it's definitely just the beginning, I would say, of some really exciting missions and visits to these moons of Jupiter and Saturn. Plenty of exciting things to watch out for, I think.
Yeah, absolutely. We're into the last sort of 5 minutes or so. We can ask if anyone has any more questions for Tara or for Ash. Actually, do post them, and we'll fit them. We'll just squeeze them in just before we end. I had one thing I was going to ask you, Tara. It kind of ties in. It sounds like astrobiology potentially has quite a sort of a rich future, I guess, with some of the sort of ambitions around, landing missions and more sample return missions and things like that. I mean, you didn't start off as an astrobiologist, but that even that term being an astrobiologist, has changed a huge amount in the last 10, 15, maybe 20. I don't know what the time scale is, but I don't know if people would have called themselves an astrobiologist or been confident to call themselves an astrobiologist, because people might have seen it as slightly obscure or a bit of an odd area of science, but it's definitely not now.
I think it's a relatively new sort of term and area of science. So even I'd say like the last 20 years, it might not have existed, the sort of term astrobiology, just because we didn't really know what was out there. Our knowledge of space has sort of improved vastly in the last 20 years with different missions, and with increased technology and telescopes to be able to look at what's out there, such as exoplanets. We didn't know about exoplanets until relatively recently, and now we know about loads of exoplanets, and some of those could possibly have life. So it's a really interesting area to be in, and that covers so many different sort of topics and different ways of looking at planets and moons, so looking for different ingredients and trying to understand them even better.
Brilliant. Okay, yeah, thank you so much. Yeah, absolutely. Brilliant. I'm just going to come back to Ash, if we can see where we've got to, Ash, where to the geyser, the geyser. No, I don't know how you're supposed to pronounce it. But the water outpouring, or the ocean outpouring, is definitely there on the surface, and you can start to see some the looming, impressive / slightly terrifying Jupiter, and its big red spot is there on the horizon as well. But you can start to see some of the rust as well, the rusty red color you brought out as well, which is really lovely.
Yes, all of the bands. Jupiter's pretty monochromatic in its tones, and of course, in taking into consideration its true color, it's pretty muted from what I've seen. But yeah, the great red spot is definitely, like Saturn has its rings, Jupiter has its great red spot and its glorious bands. So yeah.
Okay. Well, what we'll ask you to do, Ash, if it's okay, if you could sort of finish off throughout the rest of the day, or however, after this session, finish it off and take a really lovely picture of it. We'll put it in the we'll post it on Facebook and Twitter, and we'll put a link to it in the recording of this video, so people can sort of check back later with the recording, and they'll see the final piece, which I think will be really lovely. But yeah, thanks so much for sort of creating this as me and Tara have been chatting away. It's been a really lovely accompaniment to the conversation, I think.
Of course, I think so too.
Brilliant. Okay, and yeah, thanks Tara as well for joining us. Thank you for telling us about Clipper. I think we can all we can all look forward to it launching, and then look forward to waiting 6-7 years, and then and then waiting for it to maybe bring back its first results.
Thank you for having me.
Brilliant. So yeah, that does unfortunately bring us to an end of this sort of lunchtime discussion. Yeah, again, thanks so much, Tara and Ash, for joining us today. If you've been watching live on YouTube, and apologies if we didn't get to your question or read out your thoughts. A recording of this discussion will soon appear, as I said, on this Great Exhibition Road Festival YouTube channel, and we'll include a link to Ash's final piece, so you can have a look at that. We are returning as a festival to an in-person weekend extravaganza. For those of you who are in London or near London or commutable to London, we're going to be back at Closing Exhibition Road, back in our home of South Kensington, across the 18th and 19th of June. So you can visit the Great Exhibition Road Festival website. There's various details there, and you can sign up to a newsletter for updates on the program, all the talks and workshops and zones of exhibits and all that stuff. Just finally, we also have a link we're going to post in the YouTube chat to an evaluation form, so you can tell us a little bit about what you thought of this event and what sort of events you'd like to see more of in the future. We'd really appreciate all your feedback. And I think that's about it from me. So yeah, thanks once again to Tara and Ash. Thanks to everyone who've been watching us at home. And yeah, good luck painting your own Europa landscapes. Have a wonderful rest of your day, everybody. Thank you very much.